look good. So you're going to have to make and help make decisions like that for folks. So always keep the looks in mind too, but the operation is important too, okay? Let's move on past that. Power requirements. Now, if you're coming up on an older house and going to add air conditioning, make sure that the power capabilities are there. Sometimes the capacity of older homes in particular may not have taken in consideration the power needed to operate air conditioning or new equipment. And you may actually have the unit sized and all those parameters solved, but when it comes time to hook it up, there's not enough power there. So don't forget that part of it. Another thing is always look at, if it's going to be a split system in particular, where is the refrigerant lines going to run? You know, nobody wants to see pipes up the side of their house. So you've got to figure out how, especially if you've got part of the unit going to be in the attic and the other is going to be on the side of the house or a house that's visible, or part of the house that's visible, take in consideration how those lines need to be hidden, if you will. That doesn't mean that you always have to tear the wall out. Sometimes you can use a gutter or something like that to make it look very neat. Also consider about where the condensate is going to go. That seems to be forgotten more so than any other thing. Laws of nature still makes water go downhill. And we can overcome that with condensate pumps sometimes, but that is another item that has to be added to the cost of the installation or the service. I have gone into places where the unit was actually in the crawl space, but there was no slope within the crawl space so that the condensate could run out. In fact, in some cases, the crawl space may actually wind up being lower than the surrounding land. Over a period of time, sometimes people change their landscape. They may actually build up around the house and things like that, and then next thing you know, you've got a situation to where the bottom bottom of the condensate pan is actually lower than the outside terrain. How do you fix that? Condensate pan. Okay. The only problem with any mechanical part is it's going to have maintenance. So, you know, if we can depend on nature to do the job, it's much better, but sometimes you can't. All right. I think we covered a good bit about mainly residential, but let me get into the commercial. Commercial AC and refrigeration. They're different, but they're the same. Air conditioning is refrigeration. It's just a higher temperature refrigeration, which now we can categorize that and go into commercial refrigeration, where we're going to have what's called high temp, medium temp, and low temp type refrigeration. A few figures here. High temp, you're looking at coil temperatures that are 20 degrees to 55 degrees. Now that's the coil temp. Generally speaking, you can add 10 to 15, or well actually 10 to 20 degrees to the coil temp and say that's what the space temp is going to be. Well, what would that be used for? First thing you think of is food storage, display cases, grocery stores. What about florists? Did y'all know that flowers are stored in coolers? Okay. But you don't want them to freeze, that's for sure, do you? They're going to be stored somewhere in the neighborhood, and don't quote me on this, even though we're on video here, but it's going to be somewhere around 50 degrees, 50, 55 degrees. Medicine. We don't always think about the medical end, but some medicines have to be kept at regulated temperatures. And that's another place that you would see that type of refrigeration. It's definitely going to be in supermarkets and things like that. Medium temp. Medium temp coil temperatures run between -10 to 30 degrees. Now, That's food storage. One of the places, we're going to go back to residential, home refrigerators. They actually use a freezer and take the air off the freezer to maintain the refrigerated cabinet. In other words, the 40-degree, or where you keep your milk, that's a working off of some of the air from the freezers, the way that works. Low temp, you're definitely going to be in commercial there. You're looking at coil temperatures between -40 to 10 degrees. You'll see this used for quick freeze and long-term storage. You know, when we say -40 degrees, that's going to take, you're not going to do that with refrigeration, residential equipment. Let me give you some examples of where things get misused. A dehumidifier. One of the problems with storing seed is you need to keep it dry. Okay? So when someone says a dehumidifier, the first thought is, I can run down to the local store, buy a dehumidifier, and put it in a cooler to keep this seed cool. Dry. One problem. That dehumidifier for a home is made to operate in ambient temperatures that people live in, which means it's going to be somewhere around 70, 75 degrees. If I stick this thing in a cooler that's at 40 degrees, it's not going to work right. I've seen this happen. Okay, commercial-wise, a dehumidifier to do something for a cooler, we're looking at the minimum cost of $3,000 to $5,000. And you know a dehumidifier for a home is not near that, what, $100 maybe? So, difference in price, different in operation. All right, let's talk a little bit about some of the systems that you would see in commercial. Single component. Single component, a reach-in self-contained unit in a grocery store. Drink machine, that's a self-contained unit. That's a single component. Everything's built into one housing. When you get into larger grocery stores though, if you had all individual equipment in there, it would be a nightmare. What they do on the bigger grocery stores is they're going to have multiple evaporators working on one compressor system, or maybe multiple compressors, sometimes called a rack system. May have multiple compressors. It may actually even have multiple or multi-stage systems within that rack, where all compressors don't run at one time. It depends on the load. The load may, the staging preferably matches the load. As the load changes, the different compressors would operate. When you get into some of the lower temperature systems, you may actually have a cascade system. A cascade system uses one refrigeration system to cool another refrigeration system that takes care of the space that's refrigerated. Where would you use that? How about a -100 degrees C? A deep, deep freezer. If you try to do all that in one stage, which can be done, but if you try to do it all in one stage, it gets complicated and very hard on the compressor system. If you use one compressor system to cool the other, to cool the unit, it's much better. You'll also see some different types of refrigeration or cooling, of active cooling systems. Greenhouses use that extensively. That is where we use the evaporation of the water going through media, wet media, to cool the temperature down to the dew point or near to the dew point. Now that doesn't work good for human comfort because it raises the humidity. Now if you're in somewhere like Arizona, that may actually be the type of air conditioning systems that they would use. But here in Georgia, it's just too humid to do that for human comfort. But flowers love it, plants love it. Okay? Secondary refrigerants are used many times, especially in commercial buildings. That's where you use water or brine solution or something of that nature to circulate throughout the building. In fact, some supermarkets are doing that now. They're using a glycol solution instead of antifreeze to circulate through the evaporators, and they keep the refrigerant self-contained in the equipment room.